Good morning, everybody. What we're going to do today is we're going to complete chapter 1. What we're going to do today is we're going to discuss equations of lines parallel and perpendicular. Then we're going to talk about equations of lines in general. And then we're going to finish up by talking about inequalities. Let's start with this one. Remember, last class we talked about equations of lines. There are 3 forms. There was the point slope form, which looked like y minus y1 m x minus x1. Because you had a point, you had the x1, y1, and you had the slope m. You defined these 3 numbers. And then what we did is I gave you a point and a slope. We plugged it in there and we solved for y. We got the slope intercept form, which is the typical one everybody talks about when we talk about equations of lines. Y equals mx plus b. Again, the slope is m and the y-intercept is b. Remember, anytime x equals 0, you get the y-intercept. You get the y value. So that's what that is. That's why b is the y-intercept. And we ended up looking at the standard form. The standard form look like this. X and y are on the same side. The only stipulation is that a has to be positive. If it's not positive, just change the signs across the board. All right. So if I give you 2 points, remember, you need 1 point and the slope to find the equation of a line, which I'll simply call EOL. So if you're given 2 points, then find the slope, choose either of the points and the slope, and plug it in there. Likewise, so that's what we did last time. Also, we introduced a discussion on parallel. Good morning. We talked about if 2 lines are parallel, for abbreviation purposes, we'll simply use that little symbol. This is line 1, this is line 2. How can you tell if 2 lines are parallel? The slopes are the same, but their y-intercepts are different. They're not equal. So therefore, since the 2 lines don't cross, you have no solutions. A solution is where the 2 lines intersect. Another example of when two lines have the same slope, if they are the same line. If they're the same line, this is my X and this is my Y. This is my X and that's my Y. So here, the two equations have the same slopes, but they also have the same y-intercept. So two lines have the same slope and the same y-intercept. If they are the same line, then they have an infinite number of solutions because each point is a solution. So these two are when the slopes are the same. If the slopes are different, if they're not equal, then we have another condition. One example is if they form a 90-degree angle. Here, clearly we can see the slopes are different. This is line 1, and this is line 2. If they form a 90-degree angle, we call those two lines perpendicular. And that symbol is simply the upside-down T. And since they do intersect, they have one solution. And then anything else fits in this last category. They have one solution. So the only thing we know here are the slopes are not equal. So now we haven't talked about the slopes of the perpendicular lines. The slopes of the perpendicular lines are opposite signs and flips of each other. They're reciprocals of each other. So if this one's a negative, the perpendicular is positive. If this is 2/4, this is 4/2. So it's just flips of each other. So these are the four possibilities if we have two lines. And then also, the reason we need to know this is because if I give you the equation of line 1 and one point of line 2, you can find the two equations. But before we do that, let's look at these examples. And here we have the four types of slopes. So I want you to tell me what the slope that's parallel and the slope that's perpendicular to it. So if the original slope is -3, the slope parallel, according to our chart here, if the slope is parallel, that means they have the same slope. So that means this one's going to be -3. That's slope. That's the slope parallel. The slope perpendicular, so these are the same slope. The perpendicular ones change sign and flip. So since this is -3, it's actually -3/1. So this one, as that's negative, this one has to be positive, and this is 1/3. That's all there is to it. The second one, slope is 4/5. The parallel is the same thing. It's 4/5. So the slope perpendicular, it's positive, so this one has to be negative, and flip this one. So it's 5/4. Zero is the same thing as 0/1. So the slope parallel is 0. The slope perpendicular, 0 doesn't have a sign, so it can't change a sign. But we can flip it. It becomes 1/0. Well, this one is 0/1, which is 0. How many times does 1 go inside 0? 0 times. But how many times does 0 go inside 1? Infinite. So that's why this is called undefined. So if we see a slope that's undefined, we know that it's 1/0. So this parallel slope is also going to be undefined. Which is 1/0. So that means the perpendicular one will be the flip of it, which would be 0/1, which is 0. Now, why do we have to know all this stuff? Let's find equations of lines. Here's an example. Find the equation of the line parallel to the line 3x plus 2y equals 6. Going through the point 4, -5. It's one of those mornings. If you want to take a picture, oh, actually, I'm going to send this to y'all this afternoon. So find the equation of the line parallel to the line 3x. So here are my steps. Find the slope of the first line. So how do we do that? Set as y equals mx plus b. Or solve for y. We have to get rid of the x first. So we have 2y equals negative 3x plus 6. Since we're trying to get y by itself and it's 2 times y, we have to divide each term by 2. So we found the slope. What's the slope of the first line? Mhm. The slope, m, is whatever's in front of the x. That's the slope. So to find the line, the equation of the line that's parallel to this one, we need 1 point and the slope. Do we have those? What's the point? Yeah, that's given up here in the question. Then the slope, that's what we just found out. Very good. Plug into the point slope formula. And solve for, next step, solve for y. Since we have a point and a slope, plug it into the point slope formula. So we take this stuff as y minus y1 equals mx minus x1. So this is x1, this is y1. So y1 is negative 5. The slope is negative 3/2. And x1 is 4. What's my next step? First off, you can't have two, we have parentheses. Can we do anything inside the parentheses? Can we?
Yeah, on the right side, and 3/2, 3/2 multiply.
Well, no. First, can we do anything inside it? Can we do anything with x minus 4? Can we do anything with this one? No, we can't do anything inside the parentheses. So we have to get rid of the parentheses. Negative times negative becomes a positive. So it's y plus 5 equals negative 3/2 x minus 4. When dealing with mathematics, the fewer methods you learn, the better it is. If you're going to learn something that'll work all throughout, no matter what. So I know what you're going to say here. It's not wrong, but it's another method. You were going to say distribute in there, but then you'll still be left with a fraction. And then you have to worry about fractions, possibly. Because the next example I'm going to give you is have nothing but fractions everywhere. So how do we solve for y? First, get rid of the fractions. And this method always only has 5 steps. First step, what is the LCD of that equation? In this equation, what's the LCD? What does LCD stand for? Yeah, the least common denominator, yes. So what's the smallest denominator that all the bottom numbers fit into? 2. Yeah, it's the only denominator. So what do we do with that is multiply each term by the LCD. How many terms do we have in this equation? What is a term? No. I see why you're going to say 4, but no. It's actually 3. A term is anything separated by a plus, minus, or equals. So here's a plus, and here's an equals. That one doesn't count because it's inside of parentheses. And that's a negative sign, so that doesn't count. So we have 1 term, 2 terms, 3 terms. Even though it looks pretty big, because it's in parentheses, it's multiplication. It's 1 term. So multiply each term. So I take this LCD and just put it in front of each term. I'm multiplying each term by the LCD. Now, why did I do that? Is because of the next step. Whenever you're multiplying fractions, before you multiply, always reduce. Before you multiply fractions, always reduce. I'll show you why also in a second. So nothing can cancel on the bottom here, nothing here, but this one can cancel. This 2 here and this 2 here cancel. So that 2 cancels that 2. So this is what we have right now. 2y, 2 times 5. There's nothing there anymore. These 2 equations are the same thing. Which one looks easier to solve? And that's the reason, because we got rid of the fractions. Now we can go ahead and do what we're supposed to do. Step 4 is multiply to get rid of the parentheses. Multiply each term. So it's 2 times y is 2y. 2 times 5 is 10. Now distribute over here. Negative times positive is negative. 3 times x is 3x. Negative times negative is positive. 3 times 4 is 12. And whenever you multiply, get rid of parentheses, combine like terms if possible. And the last one, last step, step 5 is solve. Solve for y. So how do we solve for y? We have 2y plus 10 equals negative 3x plus 12. We're trying to get y by itself. Are there any y's over here? No. So we have to move everything that's not a y to the other side. Start by getting rid of anything plus or minus. So we have to get rid of the 10. How do we get rid of the 10? Minus, because it's opposite of plus. Minus 10, both sides. I cannot subtract 10 from 3x because apples and oranges. This one has it. So we just have 2y equals minus 3x, positive 12, negative 10. 12 is bigger, so the answer is positive. 12 minus 10 is 2. How do I get rid of the, what do I have to get rid of now? That's a how. Why divide? Very good, because they're multiplied. Opposite is division, each term separately. Y equals negative 3/2 x. 2 divided by 2 is 1. So here's my, okay. This is where you're going to hate me. No, actually, this is this one. You're good. So this is our equation of line. Parallel to 3x plus 2y equals 6. Going through the point 4, negative 5. That's what we found. So see, we'll do another one. But I gave you the whole roadmap there. I give you all the steps needed. No matter what kind of equation you have. If you're asked to solve an equation of a line that's parallel or perpendicular, then you just follow this. All right, let's do another one. Find the equation of the line perpendicular to that line. It's perpendicular to this line going through make it 5 2/3. So go ahead and follow your steps. Shoot. Yeah, but I paused it all the way up here. So what we have to do here is start off by taking the equation. We have to find the slope. We found the slope by dividing by 3. We got -5/3. That's the slope of this line. We need to find a line perpendicular to it. So the perpendicular to slope -5/3 is change the sign and flip the fraction. So our slope is going to be +3/5. Going through the point 5 2/3. Plug this information into the point slope formula. That's what we did here. We have y minus y1 equals m, which is 3/5, x minus 5. Get rid of the fractions. So we have fractions. So we have to find the LCD between 3 and 5 is 15. Multiply each term by 15. Cancel the fractions. 3 goes to 15 5 times. 5 goes to 15 3 times. So we have 15y minus 5 times 2 equals 3 times 2. Multiply to get rid of the parentheses. That's what we're doing here. 5 times 2 is 10. 3 times 3 is 9. We have more parentheses, so we have to multiply 9 times x. Positive, negative is negative. Positive, 9 times 5 is 45. That's where we are now. Sorry about that. So, to solve for y, what do we do?
Oh, wait, plus 10.
Yes, get rid of anything plus or minus first. So we have 15y equals 9x. They have different signs. 45 is bigger, so the answer would be negative. 45 minus 10 is 35. Next step. Now we can divide by 15 to each term. Can 9 and 15 have anything in common? 9 is made up of what? 3 times 3, right? 15 is made up of 3 times 5. So 3's cancel. So this becomes 3. This becomes 5. So it's 3/5x. How about 35 and 15? What is 35 made up of? How about 15? So the 5's cancel. So we have 7/3. There's our answer. It will take practice because I know you guys can do it. It's just that it'll just take practice because it's the steps. Once the steps click, you'll see that's easy. But right now, it's like looking at how to build a house blindfolded. So, but it's again, it always follows those steps. The beautiful thing about mathematics is it always follows certain steps. You just have to know what to do and how to do it. Just like when I said here is 15y minus 10. Everybody wants to get rid of the 15 because we get y by itself, but then that's just sitting there. So, want to do another one or move on? Doesn't matter to me. It's up to you. I mean, no. If you want to do another one, we have plenty of time because we only have one more topic left after this to finish the chapter.
Now we keep going. I said, you're gonna send all this over.
Yeah.
Okay.
Yeah, and if you guys have any, if you get stuck, if you need more help, definitely do it on Zoom. Yeah, I apologize because this past week my father passed away last November, and we've been doing the probating of the will and everything. And we had to get his house emptied to sell it. The deadline, it was supposed to be yesterday, but it was so much stuff that we had to, I mean, he had stuff in the attic and everywhere, all the closets and everything after 60 years of living in as a house. So that's why I haven't been able to respond to my messages like I was supposed to. So I promise once this weekend's finished, that house is taken care of.
You no explanation.
So, all right. Then the last thing we're going to talk about, let me see. We're going to talk about, let's see. Equations of lines, parallel and perpendicular, equations of lines. So all we have left are inequalities. I made these for you. But we're going to fill out this chart. But before we start, I have to explain the symbols we use. The symbols are on the top of the chart, but I'll give a overview of them anyway. When we're looking at a set of numbers, let's say we have 2, 3, 4, 5, 6, 7, and 8. Let's first talk about parentheses and brackets. Parentheses means do not include the end numbers. The brackets mean do include the end numbers. Okay, now what that means. So the parentheses do not include the end numbers, and the brackets mean do include the numbers. Because we're talking about inequalities, we're talking about intervals. Intervals is a series of numbers. So for example, if I gave you this, I asked you, give me all the numbers in this list. Give me all the numbers from 3 to 7. So my answer would be 4, 5, 6. Because it's parentheses, I do not include the end numbers, these and this. That's what I mean by end numbers. So if I have bracket 3 and 7, then my answer would be 3, 4, 5, 6, and 7. So, and again, we can have combinations of these things. So the answer here is 3, 4, 5, 6. Okay, now, whenever we're talking about sets of numbers, we have to use these squiggly brackets. That describes a set of numbers. So when you use these symbols, these are called intervals. So these are called interval notation. So far, so good. Another thing we have are called sets. In this one, we use these symbols. We'll point the arrows. Whenever we talk about sets, remember, this is very important. Read the statement from left to right. Here you go. And since we're talking about a horizontal line, we usually use the letter X. For example, I'll give you something like this. How would you read that?
X is less than 7.
Yes, very good. X is less than 7. The arrows always point to the smaller number. That's important. It always points to the smaller number, but you still read left to right. How would you read that? And there.
5 is greater than, X is greater than 5. So 5 is
Read
less
left,
than-
yeah.
I mean, 5 is less than X, and X is less than X. X is less than or greater to 7. Right? X is
Or
less
equal
than-
to.
or
Equal to. Yeah. 5 is less than X. X is less than or equal to 7. Let's relate these to our setup we had up here. Between 3 and 7. I would do it this way. That means 3 is less than X, which is less than 7. That means X is bigger than 3, but less than 7. 4, 5, 6. 3 is less than equal to X, less than equal to 7. Since I start here, I can include 3 and all the way up to and include 7. So it's 3, 4, 5, 6, and 7. And there's our last one. This is the same as that one. Because I can include 3. So X is bigger than 3. So it's 3, 4, 5, 6, but it's strictly less than 7. 4, 5, 6. And remember, they're sets.
Right.
So they mean the same stuff, it's just written different. And the same thing comes with pictures. When we deal with graphing, This is where it becomes a little complex depending on which book you look at. Graphing, we use open circles for not included and solid dots for included. Right. It's the shaded region that we include. And it's a horizontal axis. Remember, horizontal axis is always X's. If we had vertical, it'd be Y. So how would you read this?
Three is less than X, less than 7.
Yeah, 3 is less than X, which is less than 7. Or since I can't use the endpoints, it's 3 and 7. It's everything in between. So all this stuff is X. Which is why sometimes some books will write it this way. They'll write it that way. It's the same as these symbols. So it all depends on which author is writing the book, the chapter or not. I like to distinguish and differentiate these symbols because its own notation. So far, so good. Let's look at our chart. Well, before I move on any further, let me explain to you where the set notation really came from. Set notation, again, all this stuff started from philosophy, and in philosophy, there's a subject called logic. What this one, set notations came from this. Remember, when we deal with sets, we have to use these brackets, these squiggly brackets. Whatever is inside there is my set. So let's say I want to use it in our numbers 3, 4, 5, 6, 7. I want to use all these numbers. What it says is the set that's what this symbol means of X. These are my variables. Such that that's what that symbol means. Here's my condition. That's the way it's supposed to be written. But it's a lot of writing. So this is actually read the set of X such that X is greater than 3 and less than 7, equal to 3 and 7. So Because there's a lot of writing, we just use this part, the condition part. Because the data, the numbers you're using has to be defined. And inside here, you can say, let's say I didn't want integers. But we never went through the whole real number scheme, did we? Before going, so. When you first learned numbers in elementary school, what kind were they? What were the numbers you learned in elementary school?
All the numbers.
No. Didn't you learn these?
Yeah.
These are called the counting numbers. Why? Because if you're asked to, if I ask you to count to 10, you will start with 1. Okay, they have another one that's called, oh, they're called natural numbers. This is the formal definition. They're called natural numbers. We abbreviate it as counting because we start counting at 1. So, but there's more numbers. So we added a whole, a 0. Let's go from 0, 1, 2, 3, and so on and so forth. These are called whole numbers. That still wasn't enough because what about the other side? It's possible because once we have subtraction, we now have to worry about negative numbers. So we invented negative numbers, the whole in the middle, the 0, and everything else. We call those integers. But that's still not enough. What are we missing? We're missing numbers between 1 and 2, between 0 and 1. We're missing fractions, which are called rational numbers. Rational numbers are decimals. Decimals that end or repeat. In other words, like if I give you 1/4, that's 0.25. It's terminating. It ends. Or I can give you 1/3, which is 0.6666666666666 forever. And that's why we, in order to do that, we just write 0.6, and that line above it means it goes on forever. So those are the rational numbers. What if it's not repeating, it's not ending? We call those irrational numbers. Like pi. It has no ending, no repeating. There's another number called Euler's number, E. It's used in engineering a lot and in business. It's like 2.171811759, blah, blah, blah. It's just a never-ending number. And pi is 3.14181, whatever. So, but they're irrationals because they never stop, or then there's no repeating pattern. Rational, irrational. That wasn't enough. Because what if, but we'll call these real numbers. But are all numbers like that? No, because during calculations, we can come up with something that square root of -4. The square root symbol is asking you what number times itself equals this. Like square root of 9 is what? What number times itself equals 9? Yeah, 3 times 3 equals 9. What is square root of 25? 5 times 5 is 25. But there is no number that equals -4. If you multiply it, it's exactly the same number. -2 times -2 is 4. So we can, that's when we came up with something called imaginary numbers. You have real numbers and you have imaginary numbers. Imaginary numbers, by definition, it can be answered in 3 words. Not real. That's the formal definition of imaginary numbers, not real numbers. So everything that's not in here is in there. Which because those are the 2 types of number systems we have to put them together. We put them together in something called the complex number system. Where A is a real number and anything with an I is an imaginary. So something like -3 plus 5i, that's a complex number. -7i, that's a complex number. Or 6, that's a complex number. Because as long as it can be written like this, where A and B are real numbers, 6 can be written as 6 plus 0i. So everything's a complex number. Because it happens that when some calculations, we will come up with a negative radical. And we can't say it doesn't exist. It does exist. We just can't explain it just yet. All right. So with that, let's finish up the chapter by doing this sheet. Actually, that explanation is going to take us longer than having to do this. All right. So the first one. Let's look at the picture. We're going to be looking at this area here. This is our X that we're looking at. So using this, since it's a solid dot, we know that X is less than A. But it's a solid dot, so it's less than equal to A. Let's look at these notations. In the interval notation, the beautiful thing with the interval notation is once you see what's being used, in an interval notation is go the smallest to largest. So what's the smallest number in our list here? in the shaded region? What's the smallest number? Negative infinity. Comma, where does it end to the right? At A. So it starts off at negative infinity, goes to A. Can you ever get to negative infinity? No, it's impossible. You can never get to it. So infinity is always a parenthesis. But since A is a solid dot, we can use it, so we use a bracket. The next one. We're going to the right. So these are our X values. So X is greater than or equal to A because it's a solid dot. For the interval, what's the smallest number in our list? A. From the whole shaded part, A is the smallest, and then positive infinity is largest. A is a solid dot, so we can include it, so it's a bracket. Infinity is always a parenthesis. You can never get to it. The next one. Again, we look at what's shaded. That is your X value. X is strictly less than A. Why is it strictly less than A? Because we can't use A. It's an open circle, so we can't use A. The smallest number we have in our list is negative infinity. It starts at negative infinity and goes to A. Parenthesis. A can't be used, so it's also a parenthesis. This is my X. So X is larger than A. It can't be used, so it's no equal sign. So it starts at A and goes all the way to infinity. Infinity is always parenthesis. It's an open circle, so I have to use a parenthesis. So that's what we call infinite and open and closed. It's infinite because it goes forever one direction. Finite. What does finite mean? Yeah, it's very limited. It has a beginning and an end. So here we're looking at this data. That's my X. Let's look at X. X is larger than A, so we have A is less than X or equal to X, which is less than or equal to B. On the interval, our lowest is A, our largest is B, so it's A comma B. And they're solid dots, so we can use them, so it's bracket, bracket. I'm between there. Again, my X is between A and B, so X is greater than A, but X is less than B. But A is a solid dot, so I put a line underneath it, because I can use it, equals. A and B are is my bound. A is solid, so it's a bracket. B is a parenthesis because it's open. And the next one, here's my X. It's between A and B. So A is the smallest I can get, is less than X is greater than that, is less than B. But I cannot use A, but I can use B. I mean, include B. So we have A comma B. Is A a parenthesis or a bracket? Parentheses, and B is A. Right. Very good. And there's my X. So X is between A and B. They're both open, so there's no lines. The lowest is A, the highest is B. They're both open, so they're both parentheses. So far, so good? The next four are going to be infinite and bidirectional. What that means is they're going to go to infinity, they go opposite directions. So in this one here, it goes like this. There's my X. And here's another one over here. And there's my X. These get a little bit more complex. Because now, how would I do the set notation for this? Well, I have two possible answers. The first one, it goes from negative infinity to A. So there's my X values are less than equal to A. That's what that one says. And the next one is X is larger than or equal to B. What this is what it's telling us is if I'm thinking of a number that's less than 5 and greater than 10, it could be, your answer could be either in here or it could be here. You'd be right. So we use the word or. The answer is true in this one or in this one. Now, for the interval notation, on the first set, I go from negative infinity, comma, to A. And since A is solid, it's a bracket. And then from B to positive infinity, it's also B is a bracket. In interval notation, we use the U for union. The U stands for union because it's combining those two possible answer sets. So let's do the next three the same way. So on the left side, X is less than or equal to A. X is greater than B. Here's the question. Would it be wrong if I wrote it B is less than X? Because that's what I'm reading. Isn't B less than X? These are both the same thing. But I'll show you why this way is preferred. I mean, I'm not gonna count it wrong. If you give it to me this way, I'm not gonna count it wrong. But the reason why this is chosen, this is preferred, is if your X is on your left-hand side, look at the way the arrow is pointing. That's the shaded region. So if X is on the left-hand side, the arrow from A is pointing left. So the shaded region is to the left. X is left, so it's the shading region is going to the right of B. So if your X is on your left-hand side, let's look at here. X is greater than A. That means from A, which direction is the shaded region? It's going to the right. X is less than A. From A, I'm going to the left. That's so if you're ever if you have to graph and everything, try to get it to the left-hand side, the X on the left-hand side. And then we're going to talk about how to flip those in a second. So here we have our lowest and highest points is negative infinity, comma A. So and that's a bracket. Union with B, comma infinity. And those are both parentheses. That's an open circle. There's my X. There's my X. So X is strictly less than A because it's open circle, or X is greater than or equal to B because I can include it. Remember, if it has, since B is a solid dot, I can include it. So I have to have an equal sign. If it's an open, I cannot have an equal sign. Negative infinity to A, and A is open, so it's parenthesis. Unioned with bracket B, comma, positive infinity. Okay, last one is they're both open circles. So X is strictly less than A, or X is strictly greater than B. No equal signs. And negative infinity to A parenthesis, union parenthesis, B to positive. Now there's a pattern. You see this pattern. The next three are a little bit, now you have to start thinking about it. For A, it's a solid dot, just A. There's no shaded region. How would I represent that as a set?
X is equal to A.
Exactly. X is equal to A. How about interval notation? Which symbol do we use for a solid dot? The bracket. Does it go anywhere else? So it opens, there's A, it doesn't go anywhere, so it stops. Okay, now the next one says all of this stuff is true. How would I do that? That's the easy way. Yes, that's the easy way. Since we did this one, we could say X does not equal A. Very good. Now, if you didn't use that, if you use, because it's going bidirectional, we would have to say negative infinity to A unioned with A to positive infinity. And A is open parenthesis on both sides. Because you can't use A and you can't use A go to the right. So what would my integral notation be if I can't use A?
Would be the same as the set notation.
No. Because in integral notation, you have to use parentheses or brackets. Ooh, cricky. I put some, this one would have been X is less than A or X is greater than A. That's what it should have been. I'm sorry. I put the wrong one. You're right. This one should have been here. But a shortcut would have just been used parenthesis A, parenthesis. Now the last one. It's everything, everything. It's all real numbers. With this, let's look at the interval. What's the smallest you can get? What's the largest? Right. And in set notation, there isn't one you could say. So we just say it's R. It's all real numbers. Let's look how we solve these things. Graph that for me. Actually, put it in the other two notations. What notation is this? Set, yeah, has inequalities, so it's set notation. So I want you to give it to me in interval and graph. So how would you solve it? You have to get X by itself first. Treat it the same way if it was an equal sign. If it was 4x equals 8, what would you do? Yep. So X is less than 2. And it's always easiest if you use graphing as the intermediary symbols. So is 2, is it an open circle or a closed circle? Because there's no equal sign. Which direction is it pointing? So it's going to what number? Yes, so in interval notation, you start with the smallest and go to the largest. So I'm going from negative infinity to 2, and they're both parentheses. Give me this one in the other two notations. Again, treat that as if it was an equal sign. So what's the first thing you would do? Add 2, very good. So we have 8 is greater than equal to 4x. Then what? So 8 divided by 4 is 2. And the 4's cancel. Again, that's set notation. So we need interval. And we need graph. So what's the interval going to look like? Or the graph? What's the graph going to look like?
It's gonna be the same as the other one, which is the closed circle.
You sure? Isn't it pointing to the right?
Yeah, it should be.
No, don't doubt yourself. I mean, you might have been correct. Can we move the x to the left-hand side? If we just take this entire equation and flip it, to move the x over here, and we have the 2 here, it has to keep pointing to the x. So yes, so at positive 2, it goes to the left. You're right. So once you finish everything and x is on the right-hand side, just pick up the entire equation and flip it. And make sure that it's pointing either to the number or to the x, whatever it's supposed to point to. Very good. So far, so good? Okay, how about this? We'll have 2 more examples after this. Then I'll let you go back to sleep. As you're watching, I was getting more relaxed myself.
Yes.
First step. What's my first step? This is in set notation, so I want interval and I want a graph. You're trying to get X by itself, so we have to get rid of first. Always get rid of stuff that's not X. Get rid of the 3. We have negative 2x. 5 minus 3 is 2. Remember, never try to get away from dividing by negatives. So since X now is negative, we want to change the sign. Since we're changing the sign, everything across the board changes. Note, everything across the board changes. This changes from -2 to +2. This changes from greater than to less than. This one changes from +2 to -2. When you change the sign of X, you must change the signs of every term and the direction of the inequality. When you change the sign of X, you must change the signs of every term in the equation and the direction of the inequality. So then, since now we just divide by 2. So X is less than, strictly less than -1. So we have -1. It's an open circle and it goes to the left. Since the smallest is -infinity and the largest is -1, they're both parentheses. So in this one, give me the set notation and the graph. Again, it's always easier if you do the graph first. So our number is 4, 6, and 9. And then -infinity. So it goes from, the first part says it goes from -infinity to 4. Is 4 an open or closed circle? Because it's a parenthesis, it's open. Unioned with 6 to 9. So it's between these 6 and 9. Open or closed circles?
Close.
Yeah, because they're brackets. They're both closed. So how would I put it in set notation? Remember, set notation uses the pointy arrows and the word or. How would I write this one? Yep. X is strictly less than 4, or remember, the shaded part is the X. Where is X? So it's between 6 and 9. So it's going left or right. So 6 is less than X is less than 9. Are they equals or not? Since they're solid, and there's your answers. It just takes practice doing these symbols. And the last example I'm going to show you is something called tripartite equation. It has 3 parts, hence the tripartite. Here are the steps how to solve this one. Whatever you do to get X alone, you do to the other 2 sides. It's really one step. Whatever you do to get the X alone in the middle, you do to the outsides. So what's your first step? Remember, whatever you do to get the X by itself, what's the first thing you have to do to get X by itself? Yeah, because X is in the middle, so you subtract 3. I have to do it everywhere now. Four minus 3 is 1. 9 minus 3 is 6. Next step. And then divide by 2. I divide this one by 2, I divide this one by 2, and I divide that one by 2. Those cancel. So my answer becomes 1/2 is less than X is less than 3. That's all there's to it. And if X is negative, you change everybody's sign and you flip the inequalities. And that's all there's to it. Let's do one of those. What form is this? What notation? Is set notation. So the interval notation would be parenthesis 1/2, comma, 3, parenthesis. And the graphing would be 1/2 and 3 with circles, and it's shaded in the middle. I mean, that's what that chart we made at the beginning of the class, or middle of the class did for us. Let's do one more. We'll have a negative in the middle, and then we'll call it a week. Have at it. Let's see what we're gonna do. And then also put it in the other two forms. So what's my first step?
-2.
-3. For all three sides. -4 -3, they're both negative, so the answer is negative. So add numbers. 4 + 3 is 7. -5x. 2 - 3, 3 is bigger, so the answer is negative. 3 - 2 is 1. Next step, change the signs. Because that's negative in front of the x, I gotta change everything. Change all the signs from positive to negative or negative to positive and change the directions of the inequalities. Because it's going to be exact opposite of it. Now, since we in essence change the direction of everything, so we change the negative to positive x, let's flip the entire equation over. So 1 comes here. The arrow is pointing to the 1. The arrow is pointing to the 5. So the reason we do that is because we want to try to read it from left to right, smaller to larger. And the last step says divide by 5. So we have 1/5 is less than x is less than equal to 7/5. The graph would give me 1/5 and 7/5. X is between there. That's just so it's an open circle. This one's got a line, so it's a closed circle. What's the last notation?
Oh,
No, that's set notation. It's got pointy arrows.
oh,
So it's the interval. The interval notation is the brackets and parentheses. It starts at 1/5 and ends at 7/5. Parenthesis because it's open, bracket because it's closed. That's interval. This is set, and this is graph. And there you have it. There's the end of chapter 1. It only took us 4 weeks. That's okay. Well, I mean, we'll definitely pick up the pace, and the better we understand this stuff, the easier. But I have to ask you guys, please take your weekend and do your homework, but start memorizing the library of functions. Did y'all have that sheet? Y'all have these sheets? I gave it to you last week.
We went here last week. I think he said, the, system was down.
Yes. Okay, here you go. That's right. We couldn't log on. Yeah, but I lectured. Yes, right. I didn't give you the sheets, but I lectured and I sent the tape. Yes, thank you for reminding me. So everybody gets one.